Hi, welcome to this series of videos for pupils studying OCR 21st Century Science. This is Unit P5, which is all about electricity, and this is Lesson 6, Series Circuits. So we're going to examine what happens to current in series, potential difference in series, when you put cells in series, and when you put resistors in series. So, how do you know you've got a series circuit? Well, generally speaking, a series circuit is one where you do not have any branches in the circuit at all. You just have one continuous loop. So when I'm looking to find out whether I've got a series circuit or not, it's very simple. Is there any place for the electricity to branch off? And in this case, no. So that must be series. No branches. So if we're going to think about the current in a series circuit, if you go back to the rope model, the electrons are going to flow around this way from the negative side of the battery to the positive. If I think about the rope model that I've mentioned before, the whole of the current moves together, just like the rope does. There's no point where the rope is moving faster in one place or slower in another, and therefore, according to our definition of current, which is the rate of flow of electrons, then the current is the same in all parts. Now this is counterintuitive in as much as you might think that near the battery somehow the current is going to be bigger, but that's not true. Think of the rope model, think of the electrons all moving together, and therefore the current is the same everywhere. So if I put an ammeter here, or here, or here, or here, they will all read the same value. And that's the fundamental concept of a series circuit. Anywhere you go in that circuit, you've got the same rate of flow. Alright, let's look at PDs in series, and I already touched on this in the previous video, but if I was to measure the potential difference in each component, across each component, and I'll just put the PD of the cell itself in a different colour, just to represent the idea of energy in versus energy out. So if I've got 10 volts potential difference across my power supply, that means effectively I'm putting in this amount of energy, and so the total potential difference around the circuit will add up to 10. So this one might be 3 volts, this one might be 2 volts, and therefore the motor must be 3 plus 2 equals 5, and I need therefore that to be 5 as well in order to add up to the 10. So the 10 volt supply is then transferred into 3 volts, 2 volts and 5 volts, i.e. that lot added together equals 10 volts. Remember, energy in equals total energy out, and as we defined last lesson, voltage or potential difference is the difference in potential energy, or the energy lost. So some energy lost here, some energy lost here, some energy lost here. Now, when we look at the next part, which is the having cells in series, let's treat you to a fresh page. If I have cells in series, it's probably no surprise to know that the PD from each cell will add up. So if these are all 1.5 volt cells, which is the standard PD for a cell, then the total PD from there is 4.5 volts. So cells in series, PDs add up. No surprise. Just wanted to say as well that although you can't put an ammeter in a cell, because obviously it's a closed system, but if you could read and put an ammeter in the cell where it says the current is the same everywhere, that includes the cell. So there's a current flowing through the cell. So this might read 2 amps, 2 amps, 2 amps, 2 amps, and also the current flowing through the cell would also be 2 amps. Now, just looking at resistors in series, and we'll come back to this, but when we add resistors in series, that means one after the other with no branching, then the resistances, let's call those R1 and R2, the resistances add up as well. We'll come back to looking at resistors in series and parallel, but if you're thinking of things from the point of view of an electron moving through, clearly if there's just one resistor, then there's some opposition to the flow, and when I put 2 resistors in, those electrons have got to effectively move through 2. Or to think of it from the point of view of a cell, then the cell has got to do much more work if there's 2 resistors than if there's 1, and therefore that will affect the way the current flows. Okay, right, going to stop there. Just a quick recap then. In series circuits, there are no branches. The current is the same at every single point in the circuit, including through the cell itself. If we look at the potential differences in a series circuit, then the potential differences will always add up to the potential difference provided by the power supply, whatever that is. Thanks a lot.